Alright, this is Unit 9 for the 8th grade. Mean, median, mode, data representation. Okay, number 1. The 8th grade class at Jones Middle School conducted a survey to pick its favorite song to play at the 8th grade banquet. Which of the following measures of central tendency of the collected data is best to use to select the favorite song? Now, what are the central tendencies? The measures of central tendency. Mean, median, and mode, right. So, range is actually a variability test, but it's mean, median, mode. Those are the 3 central tendencies. Okay? Mean, median, mode. Which one would be best for picking the favorite song of the class? Mode. Because if you're taking a vote, which song are you going to pick? Yeah, the song that gets the most votes. Most is mode. Alright? So in this particular one, it's going to be mode. Easy enough. Alright. Number 2. A computer store has 6 different computer models that sell for those prices. If the manager wants to advertise the sales price of the computer stores or the store's computers, which measure of central tendency will show that the public the store has low prices? All right, so we need the mean, the median, and the mode. Well, the mode is easy. What's the mode of these numbers? 750. All right. In the median, what are the 2 middle numbers? They're already in order. 750. 750, and what's the other middle number? 500. Alright, so to find your central tendency, you want to add those together, divide by 2. When I add those together, I'm going to get 1250. 1250 divided by 2 is 625. So we've got 625. Now, the last one is mean. I always save mean to the last because it takes the longest. If we add all these up, 350 plus 450, all right, that is 800. Plus 500, that's 1,300. 2,300. And 3,800. Now, you probably won't be able to do that in your head, and that's fine. Some of you can, some of you can't. I'm just telling you right now to save time, if you add all those numbers up, you're going to get 3,800. Divided by the total number, which is 6. Alright, that goes in there 6 times. You get 20, which means you're going to get 3s from there on out. So 633.33. Alright, which one of these is the best to pick if you want your prices to be low? The median. There you go. That's number 2. I would say that is the second hardest problem on the test. And I don't think that was too hard. Number 3. Jimmy wanted to make a circle graph illustrating the results of a survey he took to find the favorite subject of students in the 8th grade. The results of his survey are indicated in the table below. If a circle graph is drawn to scale, which of the subjects would be represented by 1/9 or 11%? Alright. All you have to do is go up here and make fractions and see which one is 1/9. Now, I'm lazy, so I'm going to do 40 first, because it ends with a 0, which means it's going to be easy. So 40 out of what? What was the total? 40 over 180. That reduces to 4 over 18, which reduces to 2 over 9. Is that what we wanted? No. So if we go down to the next easy one, you got 20 over 180. That's the same as 2 over 18, which is the same as what? 1 over 9, which is what we wanted. So which subject represented 1/9? Foreign language. Questions on that one? Make the fraction reduce. Now, by all means, if you want to do every fraction from top to bottom, that's fine. I just picked 40 and 20 first because they were easy to reduce. Alright. Oh, I'll just get that. On number 4, we want to know which one of these line plots correctly show Luke's math scores that they give us. Well, if we look at every one of these, what's the first or what's the smallest number that's represented on every graph? 78. We can see the 78 up here. Alright. Well, each one of them has a 78, so that doesn't really help us very much. But what's the next number on this first graph up here? 80, 81, 82. Alright? So 82. Now, we can see there's an 82 right here. Right? Does everybody see that? Alright? So, that makes sense, but does this one have an 82?
No.
So that can't be our answer. Does this one have an 82?
No.
That can't be our answer. Does this one have an 82?
No.
So that can't be our answer, so that just leaves us with this one. That's easy. Alright, just work your way down the line. Number 5. I would say this is the hardest question on the test. Just because it deals with decimals. Melissa's making costumes for her high school play. She uses these different yards of fabric for the different costumes. They want us to determine the mean and the median. Alright, I'm going to do median first. What two numbers are in the middle? 6 and 5.75. Those add together to make 11.75. Then we divide by 2. That'll give us our median, the number that's right in the middle of them. So we get 5.875. I can tell you that number 5 will be multiple choice. All right. And then finally on the mean, all right, we got to add them all together. 4.25 plus 5.75, that adds together to make 10. Plus 6, that's 16. Plus the 10.75 gives you 26.75. Divided by 6. All right, that gives me 4 and 4 and 5 and wait, hold on. I'm not supposed to be divided by 6. So that's wrong. I'm sorry. 26.75 divided by 4. That's what I should have done. I'm sorry. So that's 6 and 6. 8, 7, and 5. So 6.6875. That's our mean. 6.6875. Sorry, I don't know why I divided by 6. Alright, that's the hardest problem. Again, it's going to be multiple choice. I just think it's hard. It's one of the harder ones because you have to deal with the decimals. Alright. Any questions on that one? Okay. Number 6. we have all of these plots, these scatter plots, that represent an athlete's energy level throughout the course of a day. We can see here that the vertical represents his energy level, and then down here is just the passing of time throughout the day. All right. They want to know which one of these conclusions down here at the bottom is supported by the scatter plot. The first one says the athletes have the most energy in the morning. Is that true? I would say athlete B has the most energy in the morning, but athlete A and C do not. They're lower in the morning. So that doesn't necessarily work. Next one, say athletes have the most energy after they exercise. Well, if we're looking at these, when did they exercise?
They did.
I mean, they're athletes, so I'm sure they did, but does it tell us?
No.
It doesn't tell us when they exercise. So how am I supposed to know if they have the most energy after they exercise? I have no idea. They got to give us that information, and they didn't. So that one doesn't work. It says the athlete's energy levels increase throughout the day. Well, just looking at C, his is going down all day pretty much, right? It goes up a little bit, but then it goes right back down. The last one says the athlete's energy levels decrease in the latter part of the day. Latter just means later. So if we look at all of them, sure enough, later part of the day, all of their energy levels are dropping off. And so that last conclusion is supported. Number 7, guys, this is one of the easiest problems I've ever given you on any test. Ever. We want to know which one of these graphs match up with this table. Well, the first thing in our table, for 2 servings, you get 300 calories. We look at the first, 2 servings, 400 calories. Doesn't work. 2 servings, 500 calories. Doesn't work. 2 servings, 300 calories. Works. 2 servings, 600 calories. Doesn't work. What a great, great question. Nobody better miss that one. It's the only one that matches up.
So how would you know what to put? Because I'm confused.
When there's 2 servings, you need 300 calories. That's what the table says, right?
Yes.
There's 4 graphs. The only one that shows 300 calories at 2 servings is the third one.
So you took the third graph?
So yeah, you would pick the third graph. There you go. Alright. Number 5. Or, I'm sorry, page 5. Number 8. The bar graph below shows the average number of minutes that students in grades pre-K through 10 use the internet in school per day. Which statement best explains why this graph is misleading? First one says the horizontal scale intervals are not consistent. So that baseline, the horizontal line, the scales that we use, those intervals are not consistent. Well, how many grades does each bar show?
1, 2,
2, right? Each one shows 2 grades. Each one. That's consistent, right? So I would say the horizontal scale is consistent, so that doesn't work. Next one says college students are not included in the graph. If you pick that one, I'm going to be mad. Who cares about college students? We're not worried about college students. We're worried about pre-K through 10. The next one, the title of the graph does not include the word minutes. Again, do not pick that answer. We're not worried about what the title of the graph says. Alright, so that's not our answer choice. The last one says the vertical scale intervals are not consistent. Now, if we look, what are our vertical scales counting up by?
No.
Now, I'm glad you said it. It said 5. Oh, no, 10.
5.
5, 10, 5, 10. Is that consistent?
No.
That is you can't just willy-nilly decide, I'm going to go up by 5. Now I'm going to go up by 10. It doesn't work that way. Alright? So, this would be the reason why it's misleading. Go ahead and leave it cracked, Brent. Because he's going to come back, I'm sure. Alright, everybody see why?
So, why?
It's not going up by a consistent amount. Okay? Alright, on the next one. For a school project, Sean recorded the number of days that it rained in his town. It rained 11 out of the 31 days in the month of May. So Sean concluded that the chances of rain in his town for any day of the year is 11 out of 31. Which of these explain why Sean's conclusion is invalid? First one. Sean did not measure the amount of rain. Are we talking about the amount of rain? No. We're talking about the chances of it raining, right? Not how much it's going to rain when it does rain. Right? So that doesn't have anything to do with the information we collected. Sean did not use data from any other month.
Nope.
Does it rain the same amount in May as it does in December?
No.
No. Or July? Or August? No. Each month is different, right? So you can't take the amount it rained in May and be like, that's the amount it's going to rain the entire year. It doesn't make sense, right? So, this is a good answer choice. This is probably why his theory is incorrect. Now, next one says, Sean did not take the average rainfall in May. Average rainfall talks about how much it rained, right? Again, we do not care how much it rained. We care how often it rained. And finally, Sean did not record the rainy days in any other town. All he cares about is his town. So we're not worried about any other town. So that is our answer right there. Alright, number 10. A company uses a bar graph below to convince people that its pain reliever B is greatly preferred to pain relievers A, C, and D. Alright. So here's a bar graph. It's showing, and if you look at this bar graph, it does look like B is way more popular, doesn't it? B is way more popular. Nobody likes C. Why would anybody want brand C? Why would anybody want to pick brand C? Brand C stinks and nobody likes it. However, this is very misleading because how many more people picked B than C? Oh, yeah, a lot. How many people picked B over C?
Me?
2. 2 people. That's like Karen and me making cupcakes, and I sell 100, and she sells 98. And I'm like, I'm so much better at selling cupcakes than you are. That makes sense. She sold 98, I sold 100. All right? This is very misleading. B is not that much more successful than the other ones. It only sold 1 more than A and D. All right? So why? All right, we got to see why is it like that. Well, the first one says the intervals are inconsistent. What are we counting up by every time? 1. We're going up by 1 every time, so that's consistent. All right, so it can't be that one. There is a break in the scale. Everybody see this thing right here?
Yeah.
That is a break. What do you think that break represents?
92.
Yeah, 1 through 92. That little squiggly line's like, oh yeah, there's 1 through 92, but we're going to skip it. Alright, it break. Alright? That break is what is misleading about this. We skipped all the way from 100 to 192. Well, that's a lot of space to just skip over, right? The vertical bars are not wide enough. If you pick that one, I'm going to hit my head against the table.
Okay.
The graph is not misleading. It is misleading, I'll tell you that right now. This is our answer right there. There is a break in the scale. Alright. Number 11. Number 11, we have a scatter plot that shows money earned and time spent babysitting. Now, I'm going to tell you right now, a lot of people are going to miss this problem. A lot of people are going to miss this problem, so they need to make sure that they're paying attention and they're watching up at the board.
I'm watching.
Alright. On the left, we show money earned. On the bottom, we show time spent babysitting. It says the number of times Amanda babysat decreased as the amount of time she spent babysitting decreased. Does this plot show anything about how many times she babysat?
Yes.
No.
It does because look, the dots are going up.
It doesn't say how many times though. It says how long.
I know she spent a total of 240 minutes babysitting. She could have done that in one session. She could have babysat an hour a day. She could have babysat 30 minutes a day. We don't know. It does not tell us that information. Since it does not tell us that information, we can't use that. The next choice is the one that at least 5 people in this classroom are going to pick, and it is wrong. It says that as Amanda babysat more often, the amount of money she earned per hour also increased. That is not true. What do you call the amount you make per hour? Not profit. That is your wage. That is how much you're getting paid. Guys, if you ever find a job that increases your per hour wage the longer you work, stick with that job because you'll be a millionaire before it's over. If you get paid $7 an hour, you're going to get paid $7 an hour whether you've worked 1 hour or 40 hours, right? That's your hourly wage. You might get at some point a raise, but it's not because of how long you've worked.
It's because how good you work.
Exactly. So, the per hour here messes this one up. The next one is the same thing. The less often she babysat, the amount she earned per hour decreased. No, she still earned the same amount per hour. The last one is an easily true statement. As Amanda increased the length of time she spent babysitting, the amount of money she earned increased. So, the longer she worked, the more money she made. That's pretty obvious, right? So that is your correct answer here. Guys, a lot of you guys are going to miss that because you're going to skip over it. You're going to go too fast.
How many questions are on this test?
15. Number 12. Which list is made up of coordinate pairs representing points in the shaded part of the coordinate plane? Alright, first table tells us -4 and 3. What's wrong with that? There are no negatives. So that's not it. In fact, I'm going to go ahead and mark out the third choice because it's got negatives on it. So, we've got 3 and 1. That's right here. That's in the shaded region. We've got 1 and 0. That's right here. Now, I don't know. That's on the line. Do they count that in the shaded region? Do they not? I don't know. I'm going to put a question mark. Then we have 6 and 3. Over 6, up 3, shaded region. Alright, so we'll come back to this one. We'll see if there's a better answer choice. We have 3 and 6. Over 3, up 6. Is that in the shaded region? No, so that's out, which means this is going to be our answer. Alright. Number 13. The number of games won by the Crows football team is twice the number of the games won by the Bobcats. -4. Alright, so let's test it out. First table. What is 4 times 2? -4. What is 5 times 2? -4. 6 times 2?
12.
-4. 7 times 2?
14.
-4. Alright, this one works. Look at the next table. What's 1 times 2? -4. Doesn't work. We look at the third table. 4 times 2 is 8. -4 is 4. Not 2. 1 times 2 is 2. -4 is -2. Not 4. First one is our only good answer. 14. There's a circle graph that does something for prom. What is numerically wrong with this graph?
Just say.
Numerically wrong.
Oh.
What does it add up to? Count again. 105%. Can the 105% of a student body do anything?
No.
No. That 5% is students that do not exist. Alright? I know coaches like to tell you give 110%, but that doesn't really exist. Alright? So 105% does not make sense. Therefore, that's your answer. You can either put it doesn't add up to 100 or it adds up to 105, whatever. Either way you want to word it. Last one. Last question of the test. Scott, Kelly, and Ryan would buy their parents a gift that cost $76.44. What is the average amount each child should pay? What am I going to do?
Divide it by 2.
Not 2.
3.
3. There's 3 kids.
Oh.
So divide by 3. Alright, so you get... Wait, did I do that right? No, I did that wrong. No. I'm losing my mind now. Alright, 25.48 is what I get. Now, if you put 25.48 like this, I'm going to count it wrong.
Huh? That was 25.48.
You need to bubble it in and write it. That's where it goes. Guys, on your benchmarks, a lot of people missed problems like this because they somehow couldn't bubble it in. If you bubble it in 25.47 and you're so close, I'm still going to count it wrong because that's what it's going to do on the STAR test. Alright? If they give you bubbles, they expect it to be easy enough that you get the exact answer. And I agree. So I'm not even looking at your work. I'm looking at what you bubble in. Alright? Alright, that's the entire test.